So today I'm going to be talking about continuity. And continuity basically means that the function is continuous. And in order for a function to be continuous at a given point, it must meet these three following requirements. The first one being that f of c, the function of the point given, must exist. The second one being that the limit f of x must also exist. And the third requirement being that the limit of f of x must equal the function of c. So let's see this in action. Let's say I give you f of x equals x plus 1 when x is less than 2 and 2x minus 1 when x is greater than or equal to 2. And say I ask you, is the function continuous at x equals 2? So, before we can say, yes, the function is continuous, we have to make sure we test all three of these and make sure that it meets all three of the following requirements. So let's start with the first one. Let's see if f of 2 exists. To do that, we're going to plug it into this bottom piece of the piecewise function because it's the one with the equal sign, and since x equals 2, we're going to be using that part. So, it'll be 2 times 2 minus 1, which would equal 3. So based on this, we can say yes, f of c exists, and we can keep going in our continuity test. So let's test the limits. To do this, we're going to take the limits of both sides and see if those match up. So the limit of x approaches 2 from the left would be x plus 1, and the limit as x approaches 2 from the right would be 2x minus 1. Let's test the left side first. Let's see if 2 plus 1, which equals 3, equals the right side, 2 times 2 minus 1, which also equals 3. Because these two add up, we can show that the limit exists and test the third qualification. Since f of c, which we got in the first one, the first rule we tested, equals 3, and that equals the limit as x approaches 2, which is also 3, we can say that the limit of f of x is equal to f of c, or the limit of f of 2 is equal to the function value of 2. Therefore, this function is continuous at x equals 2.